Let's go through problem number 16 on page 318 and see if we can figure out how the solution would work out. I took the diagram that they drew and I removed the tick marks that showed that these two angles were congruent and the tick marks that showed that these two angles are congruent, and I put an X in both places and I put a Y in both places, and I used different variables because the tick marks were different in both places, and there's no reason to assume that this triangle is isosceles nor that this triangle over here is isosceles. The first thing I wanted to do was write down what I knew about triangles. I knew that T plus X plus Y added up to 180 degrees in the small triangle, and I wrote that over here. And I also knew that the two X's in this corner, the two Y's in this corner, and the V added up to 180 degrees for the big triangle over here, and I recorded that over here. The second thing I did was think about what it said in the problem about the fact that angle T was an angle that would fit inside an equiangular polygon. Notice I changed the wording so that it would make more sense to me and make me feel better about it. I said that angle T is an angle that would fit in or be part of or be an angle in an equilateral polygon. So the first thing I wanted to know is what were the sizes for angle T. So I tried n equals 3 and found out that that would make the interior angle be 60 degrees in each of the corners, and I knew that I had to be more than 105. So that left out n equals 3, that left out n equals 4, and it started me off with n equals 5, where I calculated that 360 degrees divided by 5 was an exterior angle, and 180 minus 360 divided by 5 would give me the interior angle. So I calculated n equals 5, n equals 6, n equals 7, 8, 9, and 10. And when I reached 144 degrees for n equals 10, I realized that n equals 11 would put me over 145, and I stopped. So these are the polygons that I can get angle T from. Where does that leave us now? I put the information together and I figured out that when n was equal to 5 and angle T was 108 degrees, that x plus y, the two angles in the little triangle with 108, would add up to 72 degrees. Then I doubled everything so that I could have a 2x plus 2y number, 144, and when I subtracted 144 from 180, I got the measure of angle V. Again, when n was equal to 6 and T had 120 degrees in it, I subtracted 120 from 180 and found out what the x plus y number is. This is a very standard trick, if you want to call it, for SATs, ACTs, and math problems in general. I have no idea how big x is. I have no idea how big y is. I just know that together x plus y adds up to 60. So if I double it, I get 120, which is the number of degrees in the two remote corners of the big triangle. And when I subtract 120 from 180, I get that V equals 60 degrees. I did this over and over and over again. For each one of the T's that I found in step 2 of my process, found out what x plus y was, doubled it, subtracted it from 180, and got 77 and 1/7, 90, 100, and 108. These are the answers to the question. I can't just use any T I want, which means I can't use any N that I want. We saw over here that the only N's we could use were 5 through 10. The question is, if we're interested in shortcutting the process, is there any way we could have discovered that n equals 5 to n equals 10 were the only n's that would give us the t's we wanted? Or jumping back to page 1, whether you prefer to discover each n on its own, find out what t is, find out what v is. Even though it's a little bit repetitious, it is very comfortable. And so you have to decide in a problem like this how you want to handle it. What you saw using method 1, if you want to call it that, on the previous page was that all you need to do is be organized, understand how the information fits together, and be willing to be organized and work out the problem. However, the repetition can be a bit boring, especially for those of you who are a little bit more ambitious and a little bit more willing to explore and see what you can discover. And repetition often suggests that there could be a shortcut to finding the answers if you're willing to follow the algebra of the formulas all the way to the end and not jump to numbers too soon. We knew over here that x plus y plus t was equal to 180, and so we could get an x plus y formula and not switch immediately to x plus y as a number. In which case, if we double 2x plus 2y, we just have to double the 180 minus t and make it 360 minus 2t. And since 2x plus 2y plus v equals 180, 2x plus 2y is 180 minus v. So it's 360 minus 2t, and it's 180 minus v, so now let's put the two together. And when we solve for v, we get that v is equal to 2t minus 180. So if you wanted to stop here, you already have a bit of a shortcut. You can go straight from the t angle to the v angle directly. And if you'd like to stop now and test that out, you absolutely should. This is much quicker than what we did on page 1, but it can be quicker still. Because in order to find t, we had to go back and find n. So let's see if we can shortcut the process some more. As we saw on the previous page, if t is an interior angle of an equiangular polygon, and we know that in general interior plus exterior equals 180, so that interior is 180 minus e, and e is 360 divided by n, we can put these two together and say that t is equal to 180 minus 360 divided by n. If you double it to 2t, you get 360, 180 times 2, and 720 over n, 360 times 2 over n. The reason why I was interested in 2t was because 2t was in the v formula. So now I know what 2t equals, and v is now equal to this. So I can go straight from n to v without even finding t first if I want to stop here. However, I have a little bit of a difficulty, and the difficulty stems from the beginning of the problem. Here we are back on page 2 again, using what we know about restrictions, and realizing that n is a whole number, no fractions, no decimals for n. Remember, t could have a decimal, n can't. If we put t between 105 and 145, which are the restrictions from page 1, and we know that t is equal to n minus 2 times 180 divided by n, and we wanted to get n involved here, so that's why we use this formula. The top of the formula is the sum of all the angles in an equiangular, in any polygon actually, and because it's equiangular, we could divide it by n to find out how many degrees are in each angle. So I'm now going to take this equation, and I'm going to multiply both sides by n to get rid of the fraction. So that I have that n times t is going to equal n minus 2 times 180. So since n times t is the way my equation is written, I'm going to now adjust this formula to have an n in it. So I multiplied 105 by n, I multiplied t by n, and I multiplied 145 by n. I did this so that I could make my inequality match the equation that I got when I multiplied n times t. By doing that, I'm now allowed to replace the n times t with n minus 2 times 180, which I distributed it to be 180n minus 360. I'm sort of shortcutting this because I don't have a lot of room to write. So you might want to, on your paper, multiply both sides by n and write in the space over here n times t is equal to n minus 2 times 180, and then distribute on your paper so that when the time comes, you'll see exactly the substitution between n times t and 180 n minus 360. Because this is a rather complicated inequality, I broke it up into two halves. And I did 105n less than 180n minus 360 on this side, and then I did 180n minus 360 less than 145 on this side. This gave me bigger than 4.8, and this one gave me less than 10.2. And because n is a whole number, that made n go to 5 and n go to 10, and there are exactly the n's that we want. And instead of having to actually experiment finding t's to decide if we liked the n or we didn't like the n, we actually worked with our restrictions and our inequalities to go directly to the n's we wanted. If you put this formula together with this restriction, you can go directly from here and here to your answer. We worked with 5, 6, 7, 8, 9, and 10 because our restriction told us those are the only n's that would give us 105 to 145 for t. And then we plugged into the formula up here that's a little bit obscured possibly, and we got the 36, the 60, 77 and 1/7, 90, 100, and 108, exactly the same way we did on page 5. So you have to decide whether writing formulas and finding restrictions is more interesting to you, and then the answer becomes very, very quick and simple,